Hello everyone. We will now begin our lectures on chapter 3, starting with section 1, which is on statements and logical connectives. Now chapter 3 is on the topic of logic and reasoning. Logic plays a very important role in our everyday lives. Of course, it is the basis of all mathematics, mathematical proofs, mathematical theorems, equations. They are all based on logic. They follow a logical process and uh, they are derived. Theorems and equations are all derived from following a logical process. Other than in the area of mathematics, it's also used, applied in the area of languages. The grammar of different languages, they are all based on logic and reasoning. The syntax, it's all based on logic. In the area of computer science, uh, programming languages, the different programming languages that we use to program our computers and machines, they are all based on logic and reasoning. They follow a structured pattern which is based on logic, so to speak. And of course, the judicial system, the whole justice process is based on logic and reasoning as well. All right. These are the different topics that we will discuss in this section. We will start with understanding the history of the study of logic, starting with the Greek civilization. We will also understand logic in the English language as applied and expressed in the English language. I said that logic is widely used in the grammar of different languages. So we will see how logic is applied in the English language. Identify statements and logical connectives. Understand quantifiers and identify the negations of statements that contain quantifiers. So we will understand first what quantifiers are, and then we will identify the negations of statements that contain those quantifiers. Identify compound statements and then identify statements using the words not, and, or, if then, and if and only if. Now, it is believed that in the Western world, logic and logical thinking was initiated by the Greeks, starting with the Greek philosopher Aristotle. So, his way of processing logic and reasoning is called the Aristotelian logic. He lived during or between 384 and 322 BC, and he is regarded as the father of logic. So he came up with a system of reasoning with which he would argue, debate, and come to conclusions and convince people of certain ideas, certain thoughts, and so on. And this logic has been taught and studied for more than 2000 years. Now, much later in the 17th century, there was a German mathematician, philosopher, scientist, everything at once, someone named Gottfried Wilhelm Leibniz. He came up with a special kind of logic called symbolic logic. And in this type of logic, symbols, usually using letters, represented written statements. So we will learn a little bit about that. And he believed that all mathematical and scientific concepts could be obtained, could be derived from logic. Now, later in the 19th century, there was another mathematician called George Boole who extended the ideas of symbolic logic of Leibniz and did a lot of work, impressive work in that area. His logic later on came to be known as Boolean logic, which is widely used in the field of computer science, right? And then there is another famous person, Charles Dodson, but he is better known as Lewis Carroll, whose famous work is Alice in Wonderland. You must be all familiar with that. He incorporated many interesting ideas from logic into his writings, right? We will now start by looking into the logic in the English language, the reasoning, the logic that is inherent in our day-to-day communication using the English language, using the sentences that we put together to communicate a thought or an idea. Now, the first thing that we will talk about is called connectives. Connectives are words that help to join different thoughts together, to connect different thoughts together. For example, if I say that I will wake up in the morning and go to work, that's two different ideas: getting up in the morning and going to work. Two different ideas, but we are connecting them using the word and. So we are going to do both. We're going to wake up in the morning and then I'm going to go to work. The other one is the or. Or implies you're going to do one or the other. All right. I'm I'm thinking if I should go to the college today or just stay at home. Right? So here we connected two thoughts together using the word or. You are either staying at home or you're going to the college. Okay? And then we have another connective, which is if then. So if I study hard, then I will get a good grade. All right. So again, these are two different thoughts, but being connected using if then. All right. And then we have what's called the exclusive or. So or can be of different types. The exclusive or means one or the other of the given events can happen, but both cannot happen together. All right. So just the example that I gave you previously, I am either going to college or I'm staying at home. You cannot be at college and at home at the same time. So that is a case of exclusive, or it's also called mutually exclusive events. If you if you are at home, then you cannot be at the college. If you are in the college, you cannot be at home at the same time. All right, so that's exclusive or. And then we have what's called inclusive or, which means one or the other or both of the given events can happen. So for example, let's take these two thoughts: driving a car and wearing a red sweater. All right, so you can either drive a car or you can wear a red sweater, or you can do both. You can wear a red sweater and drive a car. Correct? So in inclusive or, you can either drive a car or you can drive or you can wear a red sweater, or you can wear a red sweater as well as drive a car at the same time. So that is an instance, that is an example of what's called inclusive or. Now we'll talk about what's called a statement. A statement is an idea expressed as a sentence that can be attributed as true or false. So a sentence that can be judged either true or false is called a statement. So labeling a statement true or false is called assigning a truth value to the statement. Statements can be of two kinds. The first one is a simple sentence or a simple statement, a sentence that conveys only one idea and can be assigned a truth value. So I will wake up in the morning tomorrow. That's a simple statement. It has only one thought, which is waking up tomorrow morning. All right. And then we have what's called the compound statement, sentences that combine two or more simple statements and can be assigned a truth value. So if I say I will wake up tomorrow morning and go to work, That's a compound statement because it connects two thoughts. It has two thoughts. One is waking up in the morning tomorrow, and the other one is going to work. All right. And the compound sentences are frequently connected using the connectives like and, or, and if thens. Now, changing a statement to its opposite meaning is called negation of a statement, right? So, negation of a statement is changing the statement to its opposite meaning. The negation of a false statement is always a true statement, and the negation of a true statement is always a false statement. So we will see some examples of this later on in our study. All right. Now, before we go into studying the logic of sentences as examples, there's one more terminology that we must know about. It's called quantifiers. Quantifiers answer the question how many, right? What quantity? So quantifiers are words such as all, none, or no, some, etc. So any word that implies quantity is referred to as quantifier. So when we say, uh, I've read all the books, that means it implies a quantity, a certain number of books, and you've read all of them. When we use the word none, I've read none of these books, that means you've read zero books, right? You haven't read any of these books. And then there's some. Some, I've read some of these books. That means I've read at least one, right? You could have read two, three, four, five, but not all. All right. So these all these words have different meanings, all right? But they do refer to quantity. How much or how many have you read, as in the case of the example I just gave you? All right. So how do we negate statements with quantifiers? So for example, if we have a statement which is all are, then the negated form of that is some are not. When we say all are going there, the negation of that would be not all are going there, right? So all are going there. The negation of that is not all are going there. So not all are going there means some are going and some are not going. All right. So we have to be careful when negating uh, the quantifiers. All right. A statement with quantifiers in them. The next example is none are. So if the form of the statement is none are, then its negation would be some are. All right. If we say none of the people did this, the negation of that means not none of the people did this. So that would imply some did that. So some are would be the correct form of negating none are instead of all are. All right. And then we have some are whose negation is whose negation would be none are. All right. That's the reverse of what we just discussed. And then finally we have some are not, and its negation would be all are. All right. So as we just discussed, the negation of each other, if it's all are, then that the negation of that is some are not. If the statement has some are not, then the negation of that would be all are. So they kind of crisscross. When it's some are, when the statement has some are in it and you want to negate it, then you have to use none are. If the statement given to you is none are, then the negation of that would be some are. All right. Now let's look into this example, which is asking us to negate the statement, some books are novels. All right. Now, if you look at the universe of books, it is true that some books are novels, but not all books are novels, right? There are books of different genres. There are poetry books and non-fiction books and short story books. Some books are novels, but not all books are novels. And so now we'll focus on the word some. Some suggests that at least one book in the universe of all books, at least one book is a novel. So we can write the true statement. It's a true statement for sure. So at least one book is a novel, correct? Now, if we were to make this statement false, then at least one book is a novel, we have to add the word not here. So that would be not, not even one book is a novel. All right. So when we add the word not, it would mean not even one book is a novel. Not even one book is a novel. That means none of the books is a novel. No book is a novel. That would be the negation of some books are novels. So let's look at the solution here, what they come up with and their explanation. So the solution says some, since some means at least one, the statement some books are novels is the same as at least one book is a novel. Because this is a true statement that's correct in real life, the negation must be false. So the negation is no books are novels. All right. So that would be make it a false statement. Now, in the previous example, we were given a statement which was true to begin with, and we made it false by negating it. So when you start with a true statement, when you negate it, it becomes a false statement. Now, this time we are given a sentence which is false to begin with. So in the previous example, we started off with the true statement that some books are novels, which means that in the entire universe of books, only some books are novels, but there are other books of different types which are not novels. That was true. This time we are given a statement which says all coins have the image of George Washington, which is a false statement because there are coins which have images of Abraham Lincoln. All right, not all coins have the image of George Washington. So we have to negate this and make it a true statement. So how do we go about doing that? All right, so I'm going to pull up the solutions at this point and see what they say. It says this is a false statement to begin with, since a penny has the image of Abraham Lincoln and so on. So its negation may be written as some coins do not have the image of George Washington. All right, so if we rewrite this sentence, all coins have the image of George Washington. If we rewrite it as some coins do not have the image of George Washington, then that would make it a true statement, right? Some coins they have the image of George Washington, whereas there are some coins that do not have the image of George Washington. Now that we have studied a little bit about negations, we'll talk about compound statements. All right, so compound statements are statements with two ideas connected together. All right, so statements consisting of two or more simple statements are called compound statements, and they are joined by these connectives, which are and, or, if, then, and if, and only if. All right. Now, in the next few slides, we'll talk about what's called symbolic logic. So we had learnt previously that symbolic logic was first started or developed by Leibniz, and then it was extended by a mathematician called George Boole who gave rise to the Boolean logic. All right, so we will start looking into that with this slide. We'll start with negation or not statements, and the symbol for that is this tilde symbol. All right, so the symbol used in logic to show the negation of a statement is this symbol, wavy symbol here. It's the tilde symbol on the keyboard, and it is read as not. So for example, the negation of P is this symbol which reads not P. All right. The other symbol from symbolic logic is used to connect and statements. So the symbol for that is this downturned V, also the hat symbol, and that's the symbol used for a conjunction, and it is read as and. So when we want to express P and Q, two statements, P and Q, then it's symbolized as P with a hat next to it, followed by Q. Okay, and then there are some other words which also symbolizes, or other words that express a conjunction other than and that's but, however, and nevertheless. So here's an example where we have to write this given statement as a conjunction in symbolic form using the symbols that we've learned so far, the not and the and. All right, so let's read what the statement is. Now recall that a conjunction connects two ideas. All right, so here in this statement, Kanye West is not on tour, but Kanye West is recording a new CD. So the connective here is the but, not the and, but the but it works the same way as the and conjunction. All right. And the two thoughts are that it's about Kanye West being or not being on tour. That's the first part of the statement. And the second part is about recording a new CD. All right. So let's see, let's symbolize, let's use a symbol to represent the two ideas. All right, so I'm going to write here that we'll use P and Q. So P is the first idea, it's about the tour. All right, so Kanye West is on tour. Let's call that P. And the Q is the other one, that Kanye West is recording a CD. All right, a CD. So the first part, let's focus on the first part of the statement. Here it says Kanye West is not on tour. All right. Now our statement P is saying that KW is on tour. So, but in the statement it says not tour, and now we know how to denote not using the tilde symbol, right? The tilde symbol expresses not. So it's going to be not, Kanye West is not on tour, so not P, all right? And then the conjunction we are going to represent as this downturned V symbol, which means but and whatever. All right, and but, however, nevertheless, and so on. Kanye West is recording a new CD is represented by the symbol Q. So it's going to be tilde P, which means not P, which is Kanye West is on tour and is not on tour, and then the and symbol, and then followed by Q, which represents KW is recording a CD. All right. Let's look at the solution provided here. Instead of P and Q, they have used T and R to represent the simple statements, or in other words, the two ideas that Kanye West is or not is on tour. And the other idea was that he's recording a new CD. All right. So instead of P and Q, they've used T and R. That's okay. It's just a different notation that they've used, or different variable they have used. So T is Kanye West is on tour, and then R is Kanye West is recording a new CD. Now we have to put them together, right? So in symbolic form, the compound statement is not T. That means Kanye West is not on tour. The conjunction symbol, and then followed by the next statement or the next idea that Kanye West is recording a new CD. So this is exactly what we came up with previously. Now let's look at another conjunctive, all right? It's actually called disjunction, and that represents the or statement. So the disjunction is symbolized by this V symbol and is read as or. In this book, the or will be the inclusive or. Remember we said that the or can be of two types. The exclusive or was you could either do this or that, but you couldn't do both together. That was exclusive or. You either do this or you do that. The inclusive or, on the other hand, is you either do this or you do that, or you could do both together. All right, so that's what inclusive or is. So the disjunction of two statements P and Q, which is represented as or, would be P and then the V symbol to denote or, and then Q. So we'll work through an example and see how we can represent this and interpret this. So let's work through an example on disjunction. So we have two thoughts which will be connected by or, by an or disjunction. So we represent the first thought, which is Camilla will take chemistry as P, and then the other thought is Camilla will take French as Q. All right. So we want to write the statement in symbolic form. Let's pull up the statement. It says Camilla will take chemistry or Camilla will take French. All right. Now again, we will use the inclusive or. That means Camilla will take chemistry or Camilla will take French, or Camilla will take both chemistry and French. So how do we denote that? When it is inclusive or, we will use the symbol, all right, this V, the V symbol to denote or. And then on the left side of this V symbol will be P, that's Camilla will take chemistry. And then to the right of the V symbol will be Q, which is Camilla will take French. So this will read as P or Q. Camilla will take chemistry or Camilla will take French. All right. So let's look at the solution. It's P, same as what we got here, P or Q. Now we can have compound statements with more than one connectives. In that case, how do we group the different statements? All right, so that's what we are going to learn now. It says when a compound statement contains more than one connective, a comma can be used to indicate which simple statements are to be grouped together. Now, when we write the compound statement symbolically, the simple statements on the same side of the comma are to be grouped together within parentheses. So let's work through an example and see how that looks like. So now we'll work through an example which will show how we can connect and write in symbolic form three ideas. So the first idea given to us is dinner includes soup, which is denoted by the letter P. And then we have the next idea, which is dinner includes salad, and that's denoted by the letter Q. And then we have R to represent dinner includes a vegetable of the day, which is the third idea. Now, how do we connect them together? These are three different ideas. So of course, we will need more than one conjunction to connect them. Correct? So let's go through the statement that we have to write in symbolic form. The statement says dinner includes soup, comma, and salad or vegetable of the day. Now, the two ideas that come after the comma will be put inside parentheses. That's what the previous slide told us to do. All right. So anything that comes after the comma, in this case, there are two ideas that come after the comma that will represent one group of ideas. And then dinner includes soup is the first idea. So the way we would go about writing that is dinner includes soup, which is P, and then it says and, so we represent the and by this downturn V, and then we use brackets to indicate salad, which is Q, and then or is a V followed by vegetable of the day is R. All right, so this is how we write a statement in symbolic logic uh, using multiple conjunction or disjunctions as the case may be. Right? So the solution is P and then within brackets Q or V. All right? Now in the next part of the question, they have the same three ideas, same three thoughts, but they have changed the position of the comma this time. All right, so it says in part B, dinner includes soup and salad, comma, or vegetable of the day. All right, so the two ideas are separated by a comma. These will be put within parentheses, within brackets. So dinner includes soup and salad will be put under inside brackets. So soup is a P. This and is going to be the a downturn V. Salad is a Q. Close the bracket, and then this or will be the V followed by R. All right, so let's see what the solution says. Solution is the same as what we got. So within brackets P and Q, and then after the brackets it's or R, which means dinner includes soup and salad. So soup and salad come together, and then or vegetable of the day. So you can either have soup and salad, or you can just have the vegetable of the day. All right, so that's what it means. Now we'll see how to go in the reverse direction. That means we will be given a statement in symbols, written in symbols, and we have to change it and write it as a statement in words. All right, so let's see what the symbolic statement is. But the thoughts that we put together are symbolized by denoted by the letter P, which is the house is for sale, and then Q, which is we can afford to buy the house. So these are the two thoughts, and these will be connected, but not as a statement in words. It'll be given to us in symbols. So write the symbolic statement in words, which is P, which is the first idea, the house is for sale, and then we have the and symbol, correct? So let's write that down here. This is the and symbol, and then the not symbol, correct? So P is the house is for sale, is for sale. And then this is the and because this is a not symbol, we have to write it as and we cannot afford to buy the house. All right, afford to buy the house. So let's look at the solution quickly. The solution is the house is for sale and we cannot afford to buy the house. Same thing as what we came up with. Now let's look at another example which has the same ideas but they are connected differently. All right, so the same ideas, P represents the house is for sale, Q represents we can afford to buy the house. But this time, the symbolic statement is, as you can see, not P. So again, let me write in words this meaning of each symbol. It's not P, but this one, this V, represents or, correct? And then we have a not again. So not P or not Q. That means the house is not for sale. So both ideas are negated in this case, correct? The tildes suggest that both ideas are negated. So we're going to write it as the house is not for sale, not for sale. And then we have the or symbol. So let's write or. We cannot, all right? We cannot afford to buy it, buy the house. All right. So again, let's go to the solutions. It says the house is not for sale, or we cannot afford to buy the house. Exactly what we wrote up here. All right. Now, another variation in conjunction of these two ideas. Let's look at that. It's not, and then we have brackets, correct? So brackets group the two ideas together. So not followed by brackets, and within the brackets we have P and, right? This is the and symbol, and this one is the not symbol, right? So how do we write a grouped idea and connect it with the not that comes before it? All right. So let's look at the solution. It says it is false. So this not is written as false. It is false that the house is for sale and we can afford to buy the house. So within the brackets, it's not negated. So we write the P and Q, these two ideas, exactly as given in the definition. So the house is for sale and we can afford to buy the house. However, this negation comes at the beginning. So it is false that the house is for sale and we can afford to buy the house. Now we'll look into if-then statements. All right. Now, if-then statements are also called conditional statements. All right. Because the word if suggests a condition has to be met in order for the next situation to happen. All right. So given that, let's look at what is said here. The conditional is symbolized by this arrow. So symbolically, we represent conditional as arrow and is read as if then. The antecedent is the part of the statement that comes before the arrow. That means the if part, all right? The if part is called the antecedent. Whatever the if condition is, it's the antecedent, and then it comes before the arrow. And the other part, which is the consequent, if something is met, then something will happen. That's the result of a condition being met. That's why it's called a consequent. So the consequent is the part that follows the arrow. So symbolically, this is how we read it. P, then an arrow, and then the Q. So P is the antecedent part and Q is the consequent part of this if-then statement. So looking at an example of writing conditional statements, we have two thoughts again. P represents the portrait is a pastel. That's one thought. And the other thought is the portrait is by Beth Anderson. All right. So how do we connect that using a conditional statement? So it says here, write the statement symbolically. And what is the statement? If the portrait is a pastel, then the portrait is by Beth Anderson. So this is a if-then statement, right? If-then statement. And the portrait is a pastel all right, this part that comes after the if but before the then is the antecedent, and the one that comes after the then statement, the portrait is by Beth Anderson, that part is the consequent. All right, the consequent. So to denote that symbolically, it would be P. All right, let me write that here, P. And then because it's if then, we have to put that arrow and then Q. So the way it's going to read is, it is if the portrait, all right, you don't write the if in symbols. This arrow suggests there's an if that goes with the antecedent. So if the portrait is a pastel, then, all right, then the portrait is by Beth Anderson. So again, the solution is P followed by an arrow and then Q. How about a slight variation in the conditional statement using the same ideas? All right, so P represents the portrait is a pastel, and Q represents the idea the portrait is by Beth Anderson. So let's look at the statement. It says here, if the portrait is by Beth Anderson, then the portrait is not a pastel. All right. So again, two thoughts, but this time Q has been put first. Q is the antecedent. The portrait, again, let's identify the antecedent. This is the antecedent that comes after the if statement but before the then. And the thought that comes after the then is the consequent, correct? Is the consequent. And in this is also a not. So how do we write that symbolically, right? So it's going to be Q first because Q is now the antecedent. So I'm going to write Q and then followed by the arrow, which represents if then, but the then is not a pastel. So it's going to be the tilde representing not followed by the P, which is the portrait is a pastel. So it's going to read as if, let me take out my pointer here, if the portrait is by Beth Anderson, then the portrait is not a pastel. Right? So again, let's pull up the solution. It says Q followed by an arrow, not P. All right? Let's look at a third variation of the conditional statement of the same two ideas. Again, P, the portrait is a pastel. Q, the portrait is by Beth Anderson. So let's pull up the statement this time. And it says, it is false that if the portrait is by Beth Anderson, then the portrait is a pastel. Now, when it's written like this, it is false. That means it's a negation, and the negation comes before the if statement. All right. So again, this will involve surrounding by brackets. Two ideas will be surrounded by brackets. So the way we are going to write it is false is going to be denoted by the tilde. All right, so there's going to be the tilde to denote it as false. And then if the portrait is by Beth Anderson, so again, Q is the antecedent here. All right, so not, and then we are going to use brackets, then put Q, which is the antecedent, the statement idea that comes after the if but before the then. And then we have the arrow, and then portrait is a pastel is P, and that is what the solution is. So let's pull up the solution now. Is not, just like we have, and then brackets Q followed by the arrow, and then P close brackets. Now we'll look at another kind of if statement, which is called if and only if statements. Now, if then statements are called conditional statements, if then, but if and only if statements, there's also a then there, they are called biconditional statements. All right. So it says the biconditional is symbolized by an arrow pointing at both ends, and it is read as if and only if. So if and only if is sometimes abbreviated as IFF, all right, if and only if. The statement P, then followed by the symbol for if and only if Q, is read as P if and only if Q. What would be an example of biconditional statements? Here it says write statements using the biconditional, and we have two conditionals. The first one given to us, represented by the letter P, is Alex plays goalie on the lacrosse team, and Q is the Huskies win the Champions Cup. So it says here write the symbolic statement in words. So let's look at the symbolic statement. It's P followed by an arrow pointing in both directions and then a Q. So that would read as Alex plays goalie on the lacrosse team if and only if the Huskies win the Champions Cup. All right, so let's see what the solution is. Alex plays goalie on the lacrosse team if and only if the Huskies win the Champions Cup. All right, it's the same as what we interpreted previously. Now let's see how the statement would read if we introduced a slight variation in the symbols in the symbolic statement. So P again represents Alex plays goalie on the lacrosse team, and Q represents the second thought, the Huskies win the Champions Cup. So let's pull up the symbolic statement. It's Q followed by the two directional arrow and then a not symbol. All right, so the two directional arrow reads if and only if. That's the biconditional part of it. If and only if, and we have the negation of P, which is not. So how would this read? It would say Q is first. So the Huskies win the Champions Cup if and only if Alex does not play goalie on the lacrosse team. All right, so let's pull up the solutions here. It says the Huskies win the Champions Cup if and only if Alex does not play goalie on the lacrosse team. So we have the negation here of P. All right, Alex plays goalie on the lacrosse team is what the statement P is, but it's negated, so we have to include a not in between. And then Q is the Huskies win the Champions Cup. And then because it's a two directional arrow, we have to say if and only if. And yet a third variation to the biconditional statement. Let's pull up the symbolic statement here that we have to work on. It says not, or so there's negation to start with, and then within brackets we have P, a bidirectional arrow, and then another negation to Q. Right? So how would we say this in words? So let's pull up the solution. This Whenever we have negation to start with, in word form we start as it is false that. So let's see whether the solutions do that. It says here it is false, and this part of the sentence, this phrase is coming from this first negation. So it is false that Alex, within brackets we have a P, which is Alex plays goalie on the lacrosse team, and then the bidirectional arrow is for if and only if And then there's negation to Q, which is the Huskies win the Champions Cup. So here we have to include a not because of the negation. So we have to say the Huskies do not win the Champions Cup. So the whole sentence is, it is false that Alex plays goalie on the lacrosse team if and only if the Huskies do not win the Champions Cup. All right. So here's a summary of all the logical connectives that we learned about in this section, with their symbols and how they are to be interpreted and their symbolic forms. So we start with negation. Negation is denoted by the tilde symbol and it's read as not. So in the symbolic form, not P means that the statement is negated. All right. Then we have the conjunction, which implies an and statement. So the symbol for that is the downturned V, and we write it as P and then and Q, where P and Q are two separate statements. All right. And then we have disjunction, which means or. The symbol for that is the V, and we write it as P and then or Q. We have the conditional, which is the if then statement, and the symbol for that is a one directional arrow pointing to the right, written as if P, and then the symbol for if then followed by Q. And finally, we have the biconditional, which means if and only if, and in that case, the symbol, the arrow points to both sides. It's a bidirectional arrow, and we write it as P if and only if symbol followed by Q. All right.